Physicist Christian Doppler of Prague, who first pointed out 150 years ago that such a change of pitch would be expected whenever a steady source of waves moved with respect to an observer. Today, we call it the Doppler shift. Approaching, higher pitch, shorter waves. Receding, lower pitch, longer waves.
Yes, about the same.
The Doppler shift is just about symmetrical. Whether source or listener moves, the effect is there.
But what do trains and trumpeters have to do with galaxies? It turns out that the Doppler shift also applies to light. By measuring changes in the wavelength of light emitted from galaxies, Hubble was able to figure out that galaxies were flying away from each other. And receding galaxies could mean only one thing. The universe was expanding. Hubble's expanding universe caused a stir because of what it implied. An expanding universe means that tomorrow it'll be bigger than it is today. This also means, of course, that yesterday it would have been smaller, the day before smaller still. And if you keep winding the clock back in time, you'd eventually arrive at a moment in history when all the stuff of the universe is clumped together in a single tiny region. It was this idea of a single point of creation that caused the big debate between the Big Bang believers and people like Fred Hoyle, who were adamant that the universe is in a steady state. In Hoyle's universe, there was no point of creation, and all matter hadn't been produced at one moment in the past. In fact, he believed new matter was forming all the time.
As you probably know, there are two forms of cosmology, what has been spoken of as the Big Bang and the steady state. There are actually many Big Bang cosmologies, and they all have the property that the universe is supposed to have started at a particular moment.
You reject this Big Bang theory, this concept of a beginning and an evolution and it going on.
Well, I do, and I always have done, for reasons that you might think are not altogether astronomical. I've always been impressed by the views of people who argued that the plants and animals on the earth, all this complexity was due to them being suddenly made in that way. We know now, since Darwin, that this is completely wrong. We had just the same story with the chemical elements. People said, well, all the different elements like sodium, oxygen, the carbon in our bodies, and so on, had always been that way. But we know this isn't true, that the oxygen that you and I are now breathing was actually made inside stars, and that the iron in our cars was made inside stars. So that the lesson that one learns from these cases is that one doesn't impress on the universe its properties in the start. Things develop out of the basic laws of physics. And I believe this must be so for the universe as a whole.
Then how is it made?
Well, I don't think it was. I think that what we can show quite definitely is that individual particles have got to be made. If I could perhaps sort of demonstrate the point of view that I have and the point of view that the other chaps have got. Suppose I draw along here a direction, just one direction to represent space.
That's the three dimensions of space.
Yes, all in one. And this way, time. Now, what the Big Bang people say is that the particles, each individual particle, is a sort of line on here, and they all start at the same moment of time. But that's to say, these are the beginning points here. But they don't give any sort of physical description of what causes them to begin. Whereas I think what one has to do is to give a correct mathematical physical description of what one means by the beginning of a particle. And I think when you do that, you don't find that they all begin at the same moment. I think you'll find that they are scattered with ends at different times, that they're all mixed together. This is what I find. And that when you give correct mathematical description to this, you'll find that the universe itself didn't have to have a beginning.
Hoyle did have a point. Nobody had ever been able to prove that the universe had a beginning. It was a purely theoretical concept.
Galaxies flying away from each other, beyond any radio sources that any of us knew about or even dreamed existed. It's just flooding in at us.
But then in 1965, the Big Bang Brigade received a big boost, thanks to a curious horn-shaped antenna in New Jersey. The horn antenna had been part of a very early satellite transmission system. But with the rapid march of technology, it soon became redundant. That's when two young astronomers from Bell Laboratories decided to adapt its use to study our galaxy instead.
That detector, a horn looking like an old-fashioned ear trumpet for a hard-of-hearing giant, sits on its hilltop in Homedale, New Jersey. Among all the listening ears in the world, it was this one that caught the crucial whisper back in 1965, the lucky start towards today's cosmology. What it sensed came from far beyond the familiar universe of the great optical telescopes. Center stage, our sun and its planets, merely one of a myriad of stars which orbit in the